I'm putting out the call for applications. We are looking to bring 2 to 3 people on the team to serve in a role kind of like a TA in a college course. There will be an on-air component to this and a pretty solid reading schedule that the group of us will all do together. I hope you love archive.org. If you think you've got the right background to read the type of literature we cover on the show, or if you need a good excuse to force yourself to read all the best papers, send me a resume. Send it to jobs@dataskeptic.com. In the subject line, be sure to put, how about podcasting assistant? Linda will probably give you a more official title, but resume's there if you think this is a match for you. In particular, as you know, on Data Skeptic, we do themes. The whole year has flown by with just natural language processing, but we're about ready to turn over January 1st. The people joining our team will be heavily involved in that. So there is a particular area that I'm hoping applicants may come from. So a bit of luck, or serendipity as the case may be. But other than that, I'm looking for people who either have a nice little publication record started, have an amazing GitHub profile, or an exceptional project dealing with machine learning or data science in some way. 2 or 3 of those is even better. Once again, resumes to jobs@dataskeptic.com. Deadline, November 30th, 2019.
My name is Manuel Mager. I am a PhD student at the University of Stuttgart in Germany. I'm studying natural language processing in the Institute of Natural Language Processing of the university. I'm working mostly on low-resource languages and in the multilingual part, specifically code switching.
Can you share the definition of an endangered language and the ways in which people study them?
First, we have, of course, those that have like 5, 10 speakers. Even there are only older people that still use that language. But there are another kind of languages that are mostly spoken by small communities, maybe 40,000 to 100,000. Those communities have the problem that they don't use their languages in, let's say, social media or online. So that will be difficult for data mining or other techniques to get all the information and get data sets to work with. Even very large languages has problems with data and can be even considered between endangered languages or low resource languages.
With those problems in mind, where can a researcher begin? If you have no data, you have no data.
Well, I study more low resource languages, not so endangered languages. Because endangered languages need a lot of study from linguists that try to gather all the information they can before the language get extinguished. But we have other languages that the usage is not predominantly in the internet or in other environments. The challenge is still to get all the existing information that is not too much and try to use this information to train our models and do research on them. So, for example, many of those communities, tribes, or even nations use those kind of languages, the low-resource languages, on private chats, on, for example, WhatsApp or Facebook, the Facebook Messenger. And that is also challenging because we can't access this data directly if we do it like on Twitter.
What is a typical data set size in terms of, I don't know if you count sentences or utterances or documents? What do you have to work with in general?
For machine translation, our datasets can be as small as 5,000 phrases up to 50,000 phrases. So this is really low resource settings. For morphology, that is a test that is widely used, we have datasets of about 1,000 words, including, we still have to do the splitting in test development and training. So actually we're training with maybe 500 instances or even less, maybe even 100 instances.
This season, as we've been covering NLP, much of my episodes have been sort of a love letter to deep learning and how much of an impact, a positive impact it's had in NLP. Are you able to benefit from using deep learning in your research?
Definitely. The first thing we discovered when we started with the research is that deep learning performs not bad in the low resource scenario, even without using techniques like transfer learning. Because there are many tricks that can be used and to try to improve deep learning on those tasks. The gains are not that huge, as in other areas, but at least we can do very interesting stuff. For example, multilingual training and adding an auxiliary task to the loss functions and stuff like that.
Interesting. Could we go a little bit into that? Because my worry as an outsider would have been that deep learning could possibly overfit on the low data set. Can you talk about how you altered the loss function to perhaps compensate for that and other challenges?
Let's take an example, the morphological surface segmentation. A morpheme is the smallest unit that has a meaning in a word. A phoneme has no meaning. So a phoneme is only part of how it sounds, but actually a morpheme has a meaning. So those languages can have a lot of more morphemes in one single word. For example, in one language, it's called Virrarica, we have seen words with even 25 morphemes in one single word. And you can construct with one single word entire sentence in English with even more information. So that is definitely not like segmenting in 3 morphemes or 4 more morphemes, but you have to take account that it can have a lot of more morphemes, one single word. The main task is to try to get the morphemes and the boundaries between the morphemes from a surface word. But the problem here is that of course, we have not that much information available. So the first thing is how can we do, let's say, data augmentation to try to improve it? If we use random data that has no segmentation, that will also help to try to give a signal to the model where not to segment. If we train the model as a multitask learning, let's say the first task is only to copy the random string to the random output string, and then using the second one, that is our actual task, then we can improve that. If we put together both loss functions about copying for the first task and for the second task, finding the boundaries, that can definitely help the performance on the system. This can be an example to show how to do it, in a very simple way.
And what sorts of methodologies do you use then when you approach the morphological segmentation problem?
The work that is published uses the sequence-to-sequence RNN. There is also other approaches doing research on the same data set that we published, used convolutional networks to do some local feature extraction and try to get on the local level and try to find the segmentation boundaries. Of course, what we really want to do is try to figure out how to use those new peak transformers that are out. But, there is still some work to do and try to find out how to use those.
Yeah, it's going to be a challenge, I imagine, maybe with the small data sets, but certainly there's got to be something there, I would assume. Once you have those morphological segments, who then uses those? Does that get handed off? Or, maybe your work is pure research, but your work will accumulate in something and either an engineer can take that and build something off of it, or it can facilitate research on top of it. What is this a building block for?
We're using it on machine translation now, so it gives like improvement of 8 points of blue above character-based machine translation setting. But it's not enough. There are also other works around where it is shown that if we compare byte-based encoding, character-based machine translation and word-based machine translation with morphemes that are correctly segmented, then the morpheme-based translation works better. But the big problem is that our actual models are not that good. So for now, it's not the best way to go on bigger data sets using this morpheme translation-based systems. But so in our dataset that are so small, the machine translation models can take advantage of the information that is given even with bad morphological segmentations.
Gotcha. And how did the seek-to-seek approach compare with the convolutional neural network approach?
Oh, it's close. They are very close. The convolutional network got a slight improvement. This paper was published in the last Seek-Morphon workshop. Our approach is like 1 year old, so it was the first one. We proposed this together with a data set. We also compared it with LSTM that tried to find the boundaries, also some CRF approaches. It seems that the neural methods are improving the previous state of the art, the non-neural state of the art. But actually, we are on about between 70 and in the best cases 80 of accuracy for those languages with a small data setup, with a low resource data setup.
So one of the things that led me first to your research was your involvement in the Naki Project. Can you tell listeners what that's all about?
The big problem is, in my opinion, that as a community, we have always looked to the most used languages on the internet to try to prove some point or try to perform experiments in NLP. Basically, NLP at some point is considered to be equal to English plus maybe other 5 languages, and everything else is low resourced. But the big problem is that in the American continent, we have a lot of different languages that are spoken by over 100 million people here. Only in Mexico, we have more or less 10 million speakers of our indigenous language. The huge issue here is that all those languages has been not included into the general research. But this also doesn't mean that there is no research available. When I started to do research on those languages, I was trying to get all the research that I could that has been done on those languages. And I found that we have actually quite a lot. I mean, that means maybe 50 papers out in different venues. But at least there is some research there. Surprisingly, we found out that even in the last years, the interest has increased. So that is a good sign. And the Naki Project is gathering all those papers, research, resources in one single place with the goal to try to promote it and maybe get more researchers into those languages. When we collected all the information for Naki, we found out that in the southern part of our continent, I mean, in the Mexican way of seeing a continent, we are only America, and then South America is only a region, but maybe it's not like that in English. Anyway, in South America, there are a lot of people speaking those languages, much more than in any other part of the continent. But there are so few research going on. So we have also not that much data for those languages, but they are really used even on on Twitter in some cases. So I would really encourage people that are interested on the topic, but also the researcher from this area to try to study those languages, because this is really sad that we're not taking the opportunity. And in the northern part, let's say from Mexico, Canada, and the US, we have much more research going on. But even, for example, in the US and Canada, even if the languages are really endangered, as in the first part of our interview. So those languages maybe are spoken by 5 people, maybe 20, 50 or of one single nation, but it is not enough. And that is, in that cases, I think the main aim is to try to do the revitalization of those languages. So the challenges are kind of different, but it would be really great to have research on almost all languages that we have in our continent. That will be great.
Obviously, every researcher is going to come to the table with their own sort of interests, but broadly speaking, what are the goals for people studying these areas? Is it preservation or translation or understanding? What do people hope to achieve?
Well, first, let's talk about the rights of the people and the speakers of those languages. Mm-hmm. I mean, if you grew up in a community, then you have the exact same right to use your language on the internet and use all the technology available as a native English speaker. And this is, I think, one of the first aims. Secondly, all those languages are really interesting in the perception of NLP research because they are completely different to what we have in other languages. In my opinion, we really can't claim that we have solved NLP if we only try to get English or other few languages from a single linguistic family. Having a broader understanding what is going on can also bring us closer to a general model that can handle all languages that are available. Those are the 2 main points. And let's say in a downstream, the idea is to have tools that really can help all the speakers from those languages to have access to technology and the internet as in an equal way to other languages. So say machine translation, summary, grammar correction, and so on.
So one way we could take that is focus entirely on translation, right? So that a user who doesn't speak English could translate at their device back and forth to and from English, so they get to use their natural language or their native language, and the machine is behind the scenes kind of working in English somehow. But of course, something can be lost in translation. What do you think is the optimal strategy for getting those services out to the speakers of the low resource languages?
First, machine translation is one of the tests that performs really bad. I must say that there is no work around that really have a good performance for machine translation now, so there are only like some approximations. Of course, machine translation is a good thing. One interesting part is that if we do the machine translation from a very complex morphological complex language, for example, all those polysynthetic languages that are very common in the American continent, to a language like English, the translation is actually not that bad. But the problem is the way around, because there are a lot of information that is lost. A sentence that is in English does not contain all the information that is needed to reconstruct it on the other side. And of course, maybe that can be handled with a strong language model on the the complex morphological language, but we have not enough monolingual data available. So those kind of problems are actually not solved. And I would invite everyone that want to do some research in interesting topics to contribute to it.
What are some good steps to help with that, or maybe ways in which people could get involved with the Naki Project in particular?
So the first invitation is that if you have any project, even marginally related to any of those languages, please share it with me, make a comment. That would be really helpful. The second one is if someone studies low-resource languages, why not try it out on a true low-resource language? I mean, we have the data sets out. There are links to all different kind of tasks. So, because it's not the same. I mean, if you only reduce the amount of data from, let's say, English to try to prove that your model actually works on those kind of languages, that is not completely true, because you're not considering the typology of the languages or some special characteristics. So the invitation is, why not include some experiments, even if those languages are not your main goal in the paper research. So, yeah.
Thanks to this week's sponsor, Brilliant.org. Brilliant is one of my favorite learning resources on the web, and I'm really excited to tell you about one of their newest courses, Search Engines. Step back for a minute and think about this. Go to any search engine, run a query. How long does it take to give you the response? Basically no time at all, right? Why do you take that for granted? That's amazing. That's the power of an inverse index. And if you're not familiar with that or need a brush up on it, Brilliant.org's search engine course is exactly what you need. It'll teach you all the algorithms and methods about how full-text search is done, how search engines index the web, and how the data they collect inform the algorithms they use to sort the results. Search is a critical piece of infrastructure at every level of the technology stack, and you should know how it works. So head over to brilliant.org/dataskeptic and check out this or any of the dozens of other amazing courses at brilliant.org. That's brilliant.org/dataskeptic. So as you had mentioned earlier, some of the languages you're studying, especially the Native American ones, are structurally different. That to me makes sense because, knowing sort of the migration and diasporas of human beings to this continent and their isolation, of course their languages would have evolved differently. What are some of the ways that that's challenging for a natural language processing researcher?
The first question is, what is a language? We have some examples. For example, Zapotec in the Mexican state of Oaxaca. It is considered to be one single language, but that is not completely true. Even the speakers from different villages can't understand the language from the other village, even if they speak the same language. So actually that can be considered like a really huge linguistic family. The variety we have is really big.
Is that due
the
to...
second?
Sorry, I was just going to follow up. I had an experience once where I met a Scottish person who was speaking English, yet we still needed a translator to understand one another.
Yes.
Is it for similar reasons or structural reasons?
No, I think there is completely similar reasons, but yeah, the problem is that the languages evolve in different directions. Mm-hmm. At some point in the history in our continent, they evolved in really different directions. So we have a huge linguistic variation in those languages. So there is another problem. There is no standardization of writing of those languages. Even if they speak the same language and the same variety, they can write it in different ways. All the surface symbols don't actually need to have the same meaning from speaker to speaker, and that adds a lot of challenges too. There are some projects that try to do the standardization of the written language, but they have not really succeeded on the level of the native speakers.
So I imagine you've worked with many different languages. Is there any one that stands out that you learned during your research as being especially interesting or a favorite?
Oh, my favorite is Virradica.
Oh, what's that?
There are two reasons behind. First, my father speaks that language. So this is a point in favor of that language. But also from so I'm a little bit biased, but also from the perspective of the complexity, this language has the most amount of morphemes per word. And it can really do really strange things. We have close to no success doing the machine translation for that language. For example, compared to Nahuatl, that we got comparably good results. So there are so many other languages out. So I mostly only worked with 5 of them, but so hopefully we can get more and more information, and then I can share it with you.
Do you have any understanding of what the impediment is on not being able to get success with machine translation?
We did a study on that, and as I mentioned to you before, it is mostly because we really, let me make an example. For example, if we say in English, give me the knife, then we really don't have much information about where the knife is, what is going on to the knife. But in those kind of languages, we have always morphemes that specify exactly what is happening to the knife. Let's say the knife is in our visual field, or is outside of the room we are, or is on something. So all those information, you have to use it if you speak those languages. That is really difficult to try to reconstruct those information, because it's not available, and maybe it's only available in the context.
Yeah.
But in many cases, the context, you really have to see what is happening if you want to try to reconstruct the context. We are really dealing with this issue of how to reconstruct information that is missing and is needed in those kind of languages.
Wow, that's very fascinating. How can you reconstruct that information?
I don't know. I mean, if someone has an answer there, I would be glad to try to do a cooperation with them, a collaboration with them.
Warmly welcome back when the paper comes out to talk about it.
Yeah, thank you.
Well, Manuel, thanks again for your time today. This has been a really interesting conversation. I look forward to sharing with the audience.